Example 1.5, constant acceleration, speeding up to the left. What is the final velocity of a tennis ball that travels initially at 2 meters per second to the left with an acceleration speeding up at 3 meters per second squared in 6 seconds? Letter B. If this ball is thrown at a point 4 meters to the left of a post, how far will it be from the post after 6 seconds? So first you write all the given. We have V initial is equal to negative 2 meters per second, negative since this tennis ball is to the left, is moving to the left, and our sign convention is to the left is negative. V final is unknown, and acceleration is negative 3 meters per second squared. Negative because our object is moving to the left and it is accelerating or speeding up to the left. So since this object is accelerating, its acceleration vector is directed towards the direction of motion, which is to the left. Thus, negative 3 meters per second squared. X naught equals negative 4 meters. Negative 4 meters because again to the left. The initial is 0. Actually, in all our calculations in this horizontal motion with constant acceleration as derived, the T initial is 0. T final here is 6 seconds and X final is unknown. For letter A, we will be solving for the final velocity. So we have three options again, the equations 1.1, 1.2, 1.3, and with a given, we can use the 1.1 to solve for the VF. We have A TF minus TO equals V final minus V initial. This is the equation 1.1. And then we transpose V, the negative VO to the left, negative VO to the left, it becomes positive VO. So we have A, we copy the left side, ATF minus TO. Then negative VO becomes plus VO equals V final. And then we substitute the given. We have A is negative 3. Acceleration is negative 3 meters per second squared times T final is 6 seconds. Minus 0 is at the initial, so we won't write that. Plus V initial is negative 2 meters per second is equal to our V final. Using your calculator, we have negative 3 times 6 here. That is negative 18. And second divided by second squared, we have meter per second for the first term. For the second term, that is just negative 2 meters per second. So equals our V final. Negative 18 minus 2, stop. This is negative 20 meters per second as the final velocity of the tennis ball. So negative because the object is moving to the left and it is greater than the initial velocity. It was 2 and now it is 20 meters per second to the left. Solving now for letter B. If this ball is thrown at a point 4 meters to the left of a post, how far will it be from the post after 6 seconds? How far? So we are looking for the final position XF. So I'm writing letter B here. XF is unknown. Now we can choose from among, again, the three equations, and we can use, with a given, we can use number 3. We have XF, or equation 1.3. XF minus X naught is equal to VO TF minus T naught plus 1/2 A TF minus T naught. I will now drop all the T sub 0, which is 0. And our X naught is negative X naught to the left. In the left side of the equation, we will transpose it to the right side of the equation. So it will become now XF is equal to VO TF. I'm just copying the first term plus the second term. 1/2 A times TF squared, and the X naught is plus X naught. Substituting the values now. VO is negative 2 meters per second. T final is times 6 seconds plus 1/2 times A is the given negative 3 meters per second squared, and T final is 6 seconds. And then there's a square there, plus X naught is negative 4 meters. Simplifying, you can use your calculator. Negative 2 times 6 plus 1/2 times negative 3, 6 squared plus negative 4 meters. Now, second over second cancel, and that cancels, and second squared over second squared, leaving meter, the unit meter for all terms, and so we can combine all the terms there. And if you use your calculator, you will get an answer of negative 70 meters. X final Therefore, the tennis ball is 70 meters to the left of the post. This is now the answer. Now we try solving example 1.5 again. But this time, we assume that the tennis ball is initially 4 meters to the right of the post, and we let it travel to the right or to the plus x. So if we sketch this is our post. And our tennis ball now, we place it to the right of the post, 4 meters. To the right of the post. So this time our V initial is 2 meters per second, positive 2 meters per second, because our tennis ball is traveling to the right. And in our sign convention, to the right is plus x-axis. And acceleration is also 3 meters per second squared, positive since the ball is accelerating, or it speeds up to the right. So its acceleration vector is the same as its direction of motion. X naught is 4 meters. Letter A, solving now for V final. With a given, we can use equation 1.1 A Tf minus T naught equals V final minus V naught. So we know that T naught is 0 in our formulation. And we want V final, so we transfer negative VO to the left side of the equation, making it plus VO. So that's VO positive plus ATF equals V final. We now substitute the given. V initial is 2 meters per second plus acceleration of 3 meters per second squared times T final. Here our T final is 6 seconds. Executing using your calculator, you will get a value of 20 meters per second. This means to say that the ball is traveling to the right at 20 meters per second after 6 seconds. Solving now for the final position, x sub f, xf use our, this time instead of using the equation 1.2, we use equation 1.3. We have xf minus x naught equals VO T final minus T naught plus 1/2 A T final minus T initial squared. I am dropping the T initial, which is equal to 0, and I'm writing x final equals, we transpose x naught to the right, minus x naught goes to the right, it becomes plus x naught plus, we copy the rest of the terms, VOTF plus 1/2 ATF squared. We now substitute the given. We have the x naught is 4 meters plus V naught is 2 meters per second. T final is 6 seconds plus 1/2 A is 3 meters per second squared, and T final is 6 seconds and square that. Executing this using our calculator, you should get 70 meters. Or here we can say that the tennis ball is 70 meters to the right of the post. Example 1.6. Glai runs towards the east and accelerates at 3 meters per second squared after passing a tree. Specifically, at time t equals 0, she is 4 meters east of the tree with a velocity of 10 meters per second. Letter A, find her position and velocity at t equals 4 seconds. And letter B, where is she when her velocity is 30 meters per second? So we have here the sketch. Glai is 4 meters to the right of the tree at t naught equals 0. So x naught is 4 meters positive because we have assigned to the right as our plus x, or to the east as our plus x. And V initial is 10 meters per second. We first solve our letter A. So for letter A, we find the position and velocity at t equals 4 seconds. Position, this is x final, and velocity, v final, at t equals 4 seconds. So here we first write all the equations so that we can choose which equation we can use in order to solve the problem. For 1.1, we have ATF minus TO equals BF minus V naught. Again, please do not be afraid which equation to use. As long as you have correctly transposed and substituted the correct given, then you will arrive at the same answer. This is the 1.2 equation I'm writing now. And then the third is XF minus XO equals VO times TF minus TO plus 1/2 A TF minus TO squared. Let me drop first the TO, because TO in our formulation derivation, TO is equal to 0. And so we have acceleration. It is given, or A is equal to 3 meters per second squared. So this is check A, and T final is 4 seconds given. V final, we are looking for this, and V initial is also available. And for the second equation, let's check. A is available, XF is unknown, VF is also unknown, X naught is given, VO is also given. For the third equation, XF is unknown, X naught is given, V naught is given, T final we have, A we have, T final we have. So basically, I'm going to rewrite again the equation numbers. Looking here, checking our equations, we can see that for 1.1, we have the VF, which is the unknown, and we are looking for this and the rest of the variables in 1.1. We have the given for those, so we can use 1.1 to solve for VF. And to solve for XF now, we see that we can use 1.2. If we can get the VF using 1.1, then you can use 1.2 by substituting the VF here into substitute VF of 1.1 into 1.2. And if you want to use 1.3, we can also do that because we have XF as the only unknown. The rest of the variables are available. But for now, we will use 1.1 to get the VF, and then we'll use 1.2 to get the XF. We can now solve for velocity VF using 1.1, and then we get the position XF thereafter using 1.2. Getting VF using 1.1. We have A TF equals V final minus V initial. We transpose, we place negative VO to the left side of the equation, it becomes positive VO. Then you copy the plus ATF equals V final. And then we now substitute the given. V naught is equal to 10 meters per second plus A is 3 meters per second squared. And T final here, we have 4 seconds. This is our V final. So this is 10 meters per second plus execute 3 times 4. That's 12. Second over second square. We are left with meter per second. So we can combine the two terms. Let me copy the 10 meters per second plus 3 times 4 is 12. And that's meters per second equals V final. So 10 plus 12 is 22 meters per second. Positive 22 meters per second means to say our object is traveling to the right or to the east. Now, after getting our VF, we can get the final position using 1.2. Or you may use 1.3, but for now we will use 1.2. Solving for XF using 1.2. 2a, I'm copying it, times xf minus x naught is equal to vf squared minus vo squared. So here we want the xf. So first we divide the entire equation by 2a. We have 2a. So we cancel. We have 2 divided by 2 and a divided by a. The left side we are left with xf minus x naught equals, we copy the term on the right side, vf squared minus vo squared over 2a. We only want xf, so we transfer x naught to the right. That's negative x naught. It becomes positive x naught plus, copy the rest of the term, vf squared minus vo squared over 2a. And we now substitute the value. X naught, we have we substitute the values the given. We have x naught is 4 meters plus vf squared, the one we solved, 22 meters per second, squared minus initial is 10 meters per second squared over 2 times acceleration, which is 3 meters per second squared. Now try executing the numerator of our fraction and the denominator. We copy first 4 meters plus 22 squared minus 10 squared. We should get a value there of 384. That's meters square over second squared over 2 times 3, that's 6 meter per second squared. Now we simplify this term. We simplify the second term. We are expected to get meters so that we can combine the two terms. So I'll copy first the 4 meters plus, let's work out the units. Meter square over second squared divided by meter per second squared, or times the reciprocal of the meter per second squared times the reciprocal of that denominator. It's second squared over meter. Cancel second squared over second squared. Meter squared over meter, we are left with meter. So 384 divided by 6 meters is 64 meters for the second term. 4 plus 64 is 68 meters. Now, to satisfy our curiosity whether all the three equations are interrelated to each other and will yield the same answer, we will solve for xf using equation 1.3. We should get the same answer, 68 meters. So let us now use equation 1.3. Because right now we have used equation 1.1.2. Using 1.3 to get XF. We have XF minus X naught equals VO TF minus T naught plus 1/2 A TF minus TO squared. I'm dropping now the TOs. And so XF is equal to X naught goes to the right side of the equation, minus X naught becomes plus X naught. It's okay if you want to write a plus sign. X naught plus VO, I'm copying the rest of the terms. VO TF plus 1/2 A TF squared. Substituting the values, X naught is 4 meters. And V naught is 10 meters per second. And our time here is 4 seconds plus copy 1/2. A is 3 meters per second squared. T final is 4 seconds. And then you square that. Executing this, we should get, copy the 4 meters and 10 times 4, that is 40. Second over second, cancel. And then here 1/2 times 3 times 4 squared, you should get an answer of 24 meters. And then you add up your X final is the same as the previous 68 meters. Same answer as the time when we have used equation 1.2 to obtain the answer. We will now solve letter B. Where is she when her velocity is 30 meters per second? So let us set up the given. We have acceleration here is still 3 meters per second squared. And T naught is still 0. And we have V naught is still 10 meters per second. X naught is 4. But here, where is she? Okay, so that's X final is the unknown. When her velocity is 30 meters per second. So that's velocity final equals 30 meters per second. So these are the given for letter B. So again, we check our equations and see which one we can use. I'm just dragging this one to the left so that we can still see the given and write our equation here. We write our 3 equations. A TF minus TO equals VF minus VO, and 2A XF minus XO equals VF squared minus VO squared. This is squared. And XF minus XO equals VO TF minus TO plus 1/2 A TF minus TO squared. I am not dropping TO since TO is 0. And we are after XF. Unknown is XF, question mark, above our XF variable. Let's now do a checking. We have A available. T final is not available. Unknown. V final is, we have this given. V initial, check. A is given. X naught is also given. V final, given. V initial, given. And we have X naught, given. V initial, we have. T final, we don't have. A, yes, we have. T final, we don't have. So looking at this, we can use our second equation to solve for XF. Or we may use the first equation, equation 1.1, and then we use the first equation so that we can solve for T final, and we substitute the T final that you have obtained into the third equation 1.3 so that we can get our X final here. Let's say we will use the second equation since we are looking for X final and it is unknown in the second equation and the rest of the variables are given. So solving for XF using 1.2. We have 2a times XF minus XO. We are now copying equation 1.2. Okay. And again, we want only the XF, so we divide the entire equation by 2a, 2a. And so we cancel 2 divided by 2 and a, we have a divided by a. And again, we have XF here. Let me draw a border there. Minus X naught equals VF squared minus VO squared over 2a. We drag this one. And now we leave XF the left side of the equation and we transfer minus X naught to the right. We have X final equals positive X naught, copy the rest of the term, plus VF squared minus VO squared over 2a. So we now substitute the given. X naught is 4 meters plus V final is 30 meters per second, and then you square that, minus V initial is 10 here, 10 meters per second over, the over is only applies to the second term, over 2 times A is 3 meters per second squared. And so we have using your calculator, 4 meters plus 30 square minus 10 square is 100. 800 meters square over second square. Let me drag this one. Over 2 times 3, that's 6 meter per second squared. And so let me work out first the unit. We have meter squared over second squared divided by meter per second squared, or meter squared over second squared times the reciprocal of the denominator, meter per second squared, is second squared over meter. Cancel second squared, meter squared over meter. We are left with meter, which is correct. We can combine this one with the 4 meters. So 800 divided by 6 using your calculator is 133.33. That's repeating. I'm placing a bar there. Meters plus 4, so 137.33 or 137.3 meters. Our X final. If you're going to use equations 1 and 3 to solve this problem, you will arrive at the same answer. If it will differ a bit, then it is because of the rounding off. Thank you for listening.